So that said, I'm going to go ahead and introduce Sasha. He's going to lead you down the 101, and then we have Corey talking about 102. You guys are in very good hands tonight. These guys know what they're talking about and are awesome. So give it over to Sasha.
Thanks, Ken. Hey, everyone. Good to see you all. Finding a venue has become kind of difficult for events this large. It was fine when we were hanging out in some dungy restaurants. And now we're at the pinnacle. Now we're at Coors Field. It's all downhill. It's going to go back down from here. But if you know of a big venue, we'd love your help. Kent mentioned that all of us have this mission of making Denver this crypto hub. One of the ways that I've been trying to do that is by getting government officials involved, and particularly 2018 gubernatorial candidates involved. So a lot of these guys have been hearing from me, they've been getting invitations, and I want to acknowledge one of them that actually showed up here today, and that's Noel Ginsberg, A+ student sitting in the front. All right, well, let's get started on the presentation. This is my first time giving this presentation in this format with these slides, so pardon me, I'm going to be standing in front of the podium looking at notes a little bit more than I like to. This presentation, we're going to talk about what is Bitcoin, what is Ethereum. Ken's going to give us some more technical previews of what happens behind the scenes in the blockchain. What this isn't going to be about is it's not going to be about investing, it's not going to be about ICOs or hard forks. So this idea of Bitcoin and digital money has been around for a long time. It was written about in these futuristic novels, and I want to start you off with a clip by Milton Friedman from 1999.
So that I think that the internet is going to be one of the major forces for reducing the role of government. The one thing that's missing, but that will soon be developed, is a reliable e-cash. A method whereby on the internet you can transfer funds from A to B without A knowing B or B knowing A. The way in which I can take a $20 bill and hand it over to you, then there's no record of where it came from. And you may get that without knowing who I am. And that kind of thing will develop on the internet, and that will make it even easier for people to use the internet. Of course, it has its negative side. It means that the gangsters, the people who are engaged in illegal transactions will also have an easier way to carry on their business.
Kind of crazy, right? 1999, Milton Friedman's talking about this. And he's talking about it because we've kind of attained this libertarian wet dream of sorts, because we have this free market society, but the medium for the free market society, our money, is this centrally planned resource. Decentralized money is a solution for that, if you see that as a problem. So Bitcoin borrowed from lessons of the decentralized web. One of the awesome things about Bitcoin was that it didn't have that much novel technology within it. It just put together all these other technologies that have been developed over the last 30 years into a system, into a congruent system, and a very elegant system. So who remembers Napster? You were downloading Metallica albums, right? Probably around that Milton Friedman speech. And then what happened? A year in, a court shut them down. And sure enough, pretty quickly we had Kazaa and all those peer-to-peer networks, right? I don't want to hear the filth you were downloading there. But it was a little bit more decentralized, but shortly thereafter we started hearing stories about college students being sued for $20 to $1 million, right? $20,000 to $1 million for piracy. So that system didn't work out too long, and then eventually Kazaa got shut down. And then we had the ultimate solution, torrents, right? The Tor network and the torrent technology, which we all use now for legitimate or illegitimate purposes, but now this network is unstoppable because it's a protocol. Bitcoin follows this decentralized web trend. We had kind of this Napster moment for digital money, and that was eGold. eGold set up this similar idea where you could trade digital money, but it was backed by gold. And I think it was around for like 2 years before a court shut it down, and the founders were arrested for, I don't know, money laundering and or illegal money transmittal, but then, you know, it turns out they were just like, look, we just made this system. So, the Bitcoin white paper. How many of you have seen this white paper? Yeah, it's a pretty cool document. I think it's only 9 pages long, and it comes out really in the depths of the recession, 2008. It's called Bitcoin, a peer-to-peer electronic cash system by Satoshi Nakamoto. No one knows who Satoshi is. We assume he's a man because Satoshi is a male Japanese name. He writes in native English. He's considered a genius, but he's totally anonymous. Nobody knows who he is. A lot of speculation. The idea that there's really only a handful of people that could have put together a system like this. And Satoshi invents Bitcoin. So he's famous in our world, and whoever he is, if he's still alive, he's a billionaire. Bitcoin, in its really basic explanation, is digital money. Now, this idea of digital money is 2 antithetical concepts. Digital makes things good to copy, easy to copy, right? The incremental cost of copying something digital is nearly 0. Money, you want it to be impossible to copy, right? Money needs scarcity for value. Digital money existed prior to Bitcoin. We had digital money before, but there was always this trusted third party. So a common trusted third party that we can talk about is PayPal. When I send you money on PayPal, I'm not actually sending you dollars, I'm sending you representations of dollars. We can call them PayPal bucks because the dollars themselves sit in the same bank account, right? The dollars aren't moving, but PayPal has this ledger of who owns PayPal bucks. Bitcoin flipped this idea of the private ledger on its head. So let's talk about the private ledger real quick. The core of PayPal's technology is just a simple ledger. It says how much money you have, how much money I have, and everything around that is to facilitate. It's kind of like a front end, right? It's really not complicated, but the security around it's really complicated. We don't want anyone to find out how much money you have, because if they can find out how much money you have, they can erase your name next to it, put their name next to it. So PayPal has this system to securitize it. Bitcoin flipped this idea on its head. It said the private ledger will no longer be private. The private ledger is a public ledger, and everybody was going to have a copy of it. And that's where this notion of decentralized comes from. Everybody has a copy of the ledger. But no one individual can manipulate that ledger. We can all interact with the ledger, right? I can send you money, your public key. I don't see your name, I only see your public key. Associated with your public key is what's called a private key. And that private key, Corey's going to talk about later, but it's a string of characters. Now we've got this ledger, and it's used by it's recorded on thousands of computers. And every 10 minutes, new transactions get recorded to this ledger. We're going to talk about how they get recorded later, but they get recorded in batches. Each batch of transactions is called a block. Each block has a cryptographic reference of the block that precedes it, and that's where we get this name blockchain. Does that make sense? Does that dispel on, kind of, a lot of people ask me, where does the name blockchain come from? Hopefully that's an easy solution. So as a result, we have this wallet system. Oh, sorry, that's the blockchain visual. So we got all the blocks, ignore the fancy words in the middle, and then we've got a reference to the previous block. So now we've got this digital money that requires no intermediary. From my mobile phone, I can send money to your mobile phone, And that money could be $1, it could be $1 million, but there's no company, there's no account registration, there's no password creation, or anything else that we normally associate with the movement of value. There's just a pair of keys, a private key and a public key. So what can we do with that? Imagine a world where my self-driving car can pay your self-driving car as it passes it on the highway, just a tiny little bit of money, tiny little increment of money. We're talking about the Internet of Things potentially being the economy of the Internet of Things, existing now because it's got a medium of transfer. And we're talking about these big futuristic ideas, but we also shouldn't discount this idea of mobile banking. It doesn't get a lot of people excited because for a lot of us, Chase and Wells Fargo works fine, right? And PayPal works fine for a lot of us. But 3 billion people globally don't have bank accounts. And that includes 20 million Americans. So now all of them have a bank right in their pocket. Now we're really early about thinking a lot of these things, and like Kent said, this feels like Internet 1995. We don't really know what's next. I can't tell you what the Netflix of blockchain is going to be. In 1995, nobody would have told you Wikipedia is going to exist, right? It just kind of came along. So one common question is, what are the miners? What do they do? What do they look like? That's what they look like. They're just a bunch of machines. Pretty straightforward. But what they do is they serve a critical function on the blockchain. The blockchain requires a consensus mechanism. Who gets to write the next block on the blockchain, right? Who gets to choose which transactions belong in the next batch of transactions? That's what the miners are there for. All of the miners are racing to solve a random math problem. That math problem adjusts in difficulty so that it gets solved approximately every 10 minutes. And then they say, I solved this problem, and they publish the solution to the entire network. By solving the problem, they have earned the right to publish to the blockchain. They can write the next block. So how does the miner choose which block, which transactions to include in the next block? Well, every Bitcoin wallet is going to give you this option to choose a transaction fee. 0.0007492 Bitcoin as a transaction fee to miners. And that transaction fee, you can put a 0, you can put a huge number, you can decide what it's going to be. But the miners, being these rational economic players, they choose the transactions with the highest transaction fee. Right? So all the transactions go into what's known as the mempool, and it's this temporary cache of transactions that have been unconfirmed. They're not secured by the blockchain yet. The miner says, I'm going to take this slice of transactions that pays the most amount of money in fees. I get to collect all of those fees because I'm the miner who's publishing the next block. And in addition to that, Satoshi, the creator, had this crazy foresight. He knew that there wouldn't be a lot of people on the Bitcoin network early on. So there's not a lot of transaction fees to collect if there's nobody on the network, right? And early on in the network, you could fit a lot of transactions in each block, so why pay a transaction fee at all? The only way miners could make money early on is with a mining reward. And that is how new Bitcoin gets created. So Bitcoin has this 21 million cap of Bitcoin. There will never be more than 21 million Bitcoin. It's inherently deflationary as a currency. And new Bitcoin gets created every 10 minutes with a new block. Through 2012, the mining block was 50 Bitcoins per block. So today, the value of a Bitcoin is what? 6,000, something like that? 5,000, where are we today?
5,500.
55. So $5,500 times 50 Bitcoin every 10 minutes gets minted. In 2013, there was what we call halving, and the mining block fell to 25 Bitcoin. Last year, the mining block, the reward fell to 12.5 Bitcoin. In 2020, the reward is going to fall to 6.25 Bitcoin. And so that's what this chart shows you. The amount of mining incentive via via rewards is going to drop. The transaction fees increase, but the miners should have a profitable business the entire way through. So the miners are effectively your new PayPal, but you don't trust them. It's a trustless money system. Next question that people ask a lot is, can't the government, rather they don't ask me, they say, yeah, but the government's going to shut it down tomorrow, any minute. Usually say it with that tone too. Some of you in the audience maybe. The government can make using Bitcoin illegal, but beyond that, the government doesn't have a lot of levers here. There's no company to shut down. Remember, there's no PayPal to say, stop doing this. And that's why cryptocurrencies actually got started using for illicit purchases. Oh, I'm sorry, I skipped this slide as well. Government's going to shut down Bitcoin. There's actually a website called Bitcoin Obituary. Every time a major media source says Bitcoin is dead, these guys tally it. So this was like a week ago. It's probably up to like 180 now. Every time a major media source says Bitcoin has died, it goes up quite a bit. So Bitcoin was started, really gained popularity on this website, Silk Road. And the Silk Road was kind of like the Napster of drugs. People paid on, it was like the eBay Napster of drugs. You could buy whatever you wanted on there, and you would pay in Bitcoin. And that really catalyzed Bitcoin's popularity among the internet. But eventually the FBI shut down Silk Road, and everybody had all these Bitcoins now that they earned selling drugs. And Bitcoin kind of got a bad rap early on for that. Julian Assange, I think a week ago, said, "My deepest thanks to the US government, Senator McCain and Senator Lieberman for pushing all these bankers into erecting an illegal banking blockade against WikiLeaks starting in 2010. So anybody that wanted to donate to WikiLeaks starting in 2010, the only way they could do so was using Bitcoin. The government doesn't have a lot of levers with Bitcoin. In order to shut down Bitcoin, remember Bitcoin's a protocol, like email is a protocol. You have to shut down large swaths of the internet. A protocol is a language in which computers interact with one another. So this is what shutting down Bitcoin would look like. Nobody knew that governments could actually do this until the Arab Spring. And it turned out Cisco and all these major networking service providers were selling all sorts of hardware to governments so that they could, in the event of some kind of emergency, shut down entire parts of the internet. This is Egyptian web traffic. Earlier this year, just a few months ago, Blockstream, kind of a controversial company, really early company in Bitcoin, started leasing satellite space, and they are now broadcasting the Bitcoin blockchain globally via satellite. So that if something like this were to happen, and you live in Egypt and you have a satellite connection, you can still access the Bitcoin network. So Bitcoin, cool, but now there's all these other cryptocurrencies, right? You've all heard of them. And for a while, they all used to be called altcoins, alternatives to Bitcoin. And most of them were Bitcoin clones, and they had some minor differences. So Litecoin was one of the first major altcoins, and Litecoin had a different, basically a different mining mechanism. They had a slightly different algorithm that used GPUs more than it used CPUs. All right, so what is Ethereum? Ethereum, a group of really smart people came together, led by this wonder kid, I think he was like 19 at the time, Vitalik Buterin, and they said, well, all right, well, we can host transaction data on the blockchain, right? We can host how many Bitcoins you have and how many Bitcoins I have, but what if we could host more information on the blockchain? What if we could host an entire program, a basic piece of software on the blockchain? And so Ethereum kicked off this idea of smart contracts that live on the Ethereum virtual machine. So the Ethereum network executes programs. People hold it analogous to an old calculator in terms of processing power. Doesn't have a lot of processing power, but it can host a lot of programs. So what kind of program could you write on there? Well, I'll give you one example. How about a program that says, a smart contract that says, all of you give me money for this meetup, and I have a funding target of $1,000, and if I don't hit this funding target, then all of you get the money refunded. But if I do hit the funding target, then I get to withdraw that money 30 days from now. Really simple logic, right? So that's the type of logic that was initially conceived of for the Ethereum virtual machine. But it's really novel, and it's novel because the blockchain cannot be altered. Nick Szabo, he's a really big thinker in the space, he coined this term wet code versus dry code. So he says business contracts that we interact with, they are wet code. They are susceptible to interpretation. The syntax in which they are written is the syntax of lawyers. That syntax changes jurisdiction to jurisdiction. Different people just read it differently. Laws can get changed, and that's wet code. We have a lot of arbitrary agreements around wet code. Dry code, the output's the same every time. There is no interpretation. The dry code said, if I reach my funding target of 1,000, I get that money. If I don't, it goes back. So you can think about some really basic business logic here, like an escrow service. Really similar, right? But why is trust important? You're going to hear this term trustless a lot. Truth is, Kickstarter does a perfectly fine job of what they do. We all trust Kickstarter for our $20 contributions. But where is business activity limited due to a lack of trust? And when you start searching for that, you're going to find great applications for blockchain technology. Foreign investors don't trust governments of developing nations. So they don't invest in real estate. I'm not going to put my money into a country that has unstable governments. The next government comes into power, and suddenly this land that I bought is owned by the president's cronies, right? They can just rewrite that registry pretty quickly. Land rights, mineral rights, chains of titles, they're all great uses of smart contracts on the blockchain. So what are other scenarios in which you have a database that you want numerous stakeholders to access, specific stakeholders to be able to alter sections of that database, but no one to be able to manipulate it? And we've got a lot of use cases. Some of them are for government, some of them are in business, but how about a voting system, right? Bitcoin, in its essence, is just a voting system. Who got their paper ballots recently? Isn't that crazy? The year 2017, we're getting paper ballots. Meanwhile, we've got Bitcoin, and it's really the same thing. It's just tallying votes. I'm going to give you another example. A lot of you here are working professionals and you're thinking, how do I get more involved in blockchain? How about medical healthcare records? You've got different hospitals, doctor systems, different agencies of government, patients, family members that all want to access similar records, right? But only certain people should be able to manipulate those records at certain times. So Ethereum's a platform where people are actually building stuff today. This is a Boulder-based company, Patientory, that's building a blockchain-based medical healthcare record system. That's Ethereum and Bitcoin in a nutshell. Corey, where are you? So Corey's going to go into some technicals. While he's getting set up, I thought I'd take a couple of questions. What are you guys thinking? Yeah?
When you're writing code, you might have an error in your code. How do you fix that error once you upload it to your code?
The question was, when you're writing code, you can have an error in your code. How do you fix that? We're still working on it. So a lot of you have heard of the DAO hack. The DAO is a smart contract on the Ethereum network. The DAO raised, I think, $200 million, and it was supposed to be this decentralized type of private venture capital play, where community members could vote on which projects would get funded, and they were for-profit projects. They were all blockchain-based. And there was an error in the DAO that resulted in hackers stealing a lot of money. I think that's a better question for Corey, but I think the answer is we're not 100% yet. Still working it out. Question in the front.
In a voting system, how could you connect my vote to me to ensure that he didn't vote on my blockchain?
The question was, in a voting system, how do you connect my vote to me? Well, Estonia has been working on this, but the baseline for a voting system to work is you need identity tied to the blockchain as well. And that is the biggest hurdle to implementing something like a voting system. We need those driving records on the blockchain as well. When I say driving records, I mean whatever the DMV has. A blockchain-based database for identity is thought of as the most secure database for identity, but it is a critical step for government to implement blockchain. We're going to do more Q&A. Corey's going to do his chunk. Then we're going to keep chatting, and then we're going to go to Blake Street Tavern and talk all night about blockchain.
The mic, Sasha. Hello? Can everyone hear me okay? Okay, cool. First, is anyone hungry? Like, need a little sugar in there? Okay, cool. Luckily, there's a pitcher's mound right here. So.